All right, here's the thing. It says verify the customer concern. Determine if the concern is the result of malfunction or normal operation. The first step in any diagnosis is to verify the customer's concern. Now, this is important. Is the problem happening cold or hot? Now, keep in mind, they just asking you questions, but on the test, they're going to give you scenarios, hot or cold. All right? And like I said earlier, the most important thing we're going to get to it is that revision book for ASE. To me, that's the most important book you can study, right? That composite vehicle book, the one they give out for free. That's the most important one. We're going to go through that one at last.
I got it right here.
All right. Does it need to be driven on the freeway or city streets for it to happen? Because, you know, obviously that's relating to speed and load. Is it concern of hard acceleration or deceleration? Is the concern under load or mild acceleration? Outside temperature. Here's an example. You got a code P0171. Tell me what do you see on this when you look at it?
It's cold.
That's good. Yeah, it's cold. That's the trick. That's the trick I threw in there. It's cold. So what's going on in this one?
And then it's either in park or neutral because there's no vehicle speed.
Right.
And
that's very good.
The engine load and the RPMs, it's idling. I would assume.
Mm-hmm.
I would call it idling. I mean, it's
right.
Very minimal acceleration.
Okay.
And then on the short-term fuel trim and the long-term fuel trim, I would assume it's an open loop, so there would be no control there with the short-term and long-term, right?
Right. You're close. What's happening here is that it just went. No, this works in open loop also. Okay. This car is running lean. This car is running lean, cold. Okay. All right, it's running lean cold. So in this case here, we're adding fuel. So we go diagnose this car. When we go diagnose this car, you want to diagnose this car cold. Because when it gets hot, it might go to normal again.
Gotcha.
Okay? So even though it's not exactly yet closed loop at 150 as a composite vehicle, it's still transitioning into closed loop. So it's still starting to go into closed loop, again pretty close, and it's reading, especially on a long-term fuel trim, because that reads in the open loop, right? It's reading a lean condition on a cold car. So to diagnose this, like somebody say, if this is a, what can I say? This would be like an intake manifold gasket leak. That one of them plastic intakes that leaks when it's cold but looks normal when it's hot. For example, let's say they give you these numbers right here. Then it says at 150, I got to put this on my iPad. Say at 159, that's when it's definitely in closed loop. My short term goes to 5, right? Both things. And my long term goes to 2. At 159 degrees Fahrenheit. But yet on the test, they say, could this be a fuel pump? A vacuum hose, low fuel volume, or a intake gasket leak. Now you see the things I just said? All 4 are leaks.
Yes. Right?
All 4 could cause... I said, I'm sorry. Let me say that again. All 4 could cause a lean condition, right? Say a vacuum. I'm trying to do this. A vacuum hose. Right. Let me write this out. A vacuum hose. Low fuel pressure. I'm gonna put this on my iPad soon. I'll write this out much better than this. Right now I'm using a mouse and it sucks. So vacuum hose, low fuel pressure, low fuel volume.
Yeah, low fuel.
Low fuel volume, and an intake gasket leak. Right. Now, again, all these vacuum holes can cause this condition, right? Low fuel pressure can cause this condition. Low fuel volume causes this condition, and an intake can cause this condition, right? But the clue to this, like any test, the clue is and I tell people in the class, the clue is always in the question. That's the clue versus this. Okay? In every question, there's a clue somewhere leading you to the answer. In this case here, this car on the cold transition, it was running lean, but as soon as it warmed up, it cleaned up. The other three answers that I gave you will be there all the time. An intake gasket that's leaking, presuming it's a plastic intake, will seal up when it warms up. Okay. But they gave you choices of all of them being the right answer. So something in the question is leading you to the right answer. In this case, it was the temperature.
A hose would always leak.
Yeah, a hose will always leak. Fuel pressure will always be low. Fuel pressure will always be low, and low fuel volume will always be low. It won't change with temperature. The only thing that would change with the temperature is the intake. So you're right, yes. And a freeze frame sets with a pending code, but you cannot see it until the code matures. The freeze frame attached to the code is actually from the first failure. That gets people confused sometimes. The freeze frame does not show up until the DTC or check engine light is up, and the check engine light comes on. But the freeze frame you're looking at is from the first time it failed. Now remember what this means is, in order for that freeze frame to show and the light to come on, that car would have to fail twice. It would have to run 2 trips and fail at least a minimum of 2 times. Then when that happens, the light comes on with the freeze frame, the first freeze frame. So when it fails the first time, you have a pending code with no freeze frame, no light, but you have a pending code. As soon as it fails the second time, the light will mature and come on along with the code. All right. Now what that said is that understanding that means that you can drive a car, think you fixed it, drive around a block and no light and think it's fixed, because you didn't run 2 good trips. The light won't come back up unless you check the pending codes.
Okay. We're talking about key cycles, right?
No, we're talking about drive cycles or trips like this. Right. Oh. This is a drive cycle. You can either a drive cycle runs all the monitors. A trip runs 1 monitor. This case is a drive cycle, right?
It's not like the drive cycle you would do for a SMOGG check, right?
Yes, exactly, yes. And keep in mind, also a drive cycle, not just driving the car like 50 miles and come back to the shop. People think that. Sometimes you get lucky to go through like that, but usually it's a sequence of events, right? And not just driving, it's a certain way you drive. Like you see here, like it says, start the engine, idle cold, approximately 2 minutes and 10 seconds. Then you accelerate to 20, 30 miles an hour, maintain a steady speed for 3 minutes. Then accelerate to 40 to 60 miles an hour for 15 minutes and maintain the speed. And decel, come to a stop, idle in gear for approximately 5 minutes. Each step is checking some. Oops. There you go. Each step is checking something, as you see on the bottom. Okay, that's a drive cycle. A trip is similar to a drive cycle. A trip runs 1 monitor. Let's say the cat monitor, right? You'll do a trip for the cat, or a trip for the EGR. But a drive cycle runs all the monitors. And when you hear the term monitor, it means the PCM is checking the system, or testing the system. If it passes or fails, it's another story. But the monitor is testing the system. To get that to happen, you have to do certain naming criteria for that monitor to run to check that system. If more than one code is set, the freeze frame applies to the first code set. Unless a catalyst damaging misfire or fuel trim code sets later. They always get priority. Anything that's going to damage the cat goes first.
Okay.
An example above is showing you a lean condition when a vehicle is cold, so the diagnosis should be considered during a cold operation, like I said earlier. You have to have knowledge on the system. Inspect for missing, damaged, modified, or aftermarket replacement parts. Ensure that all vacuum hoses that are connected correctly, that there is no damage. And basically what that means is that hooking up an EGR valve wrong could cause a high emission failure, like NOx. Hooking up the EVAT wrong can cause a rich condition.
Yes.
So you gotta understand how to read the vacuum diagram. All these things can cause emission failures. Now, you should know how these systems work also. Basically, before you can go into the ASE test, you need to know how the systems work. For example, in this condition here, the fuel pressure can cause a rich or lean condition and even a hard start. Now look at this. This car got high fuel pressure. Carbon monoxide is always an indication of fuel or a rich condition. High CO is indication of a rich condition. See this? And you see the CO right here.
Yeah.
Hydrocarbons will follow a gas. It usually follows AC. AC usually follows CO because the plugs are starting to fall out.
Yeah.
Okay. A low O2 reading, right? High CO and low O2 is an indication of a rich condition. Here the O2 is starting to go up because ACs are starting to go up. And usually you want the CO about 0.5, HC around 50 parts per million. Right. NOx is pretty low. But CO2 is my efficiency gas. You can see here, anything below 13% indicating something is wrong. Either the catalytic converter is not working, or you got a car running poorly, like this one. This one's running rich.
So that should be between 12 and 15%, right?
13 to 15.
13 to 15.
Yeah, a cold cat is usually around 12. As it warms up, it should go about 13 to 15%.
In this case, why is the oxygen slightly higher? It's supposed to be 0.5%, right?
And see, that's the controversy on some of these tests also. Some books say the oxygen is 1 to 2 or 1 to 3%, which is normal. But that's with an air pump though. I think they say that with an air pump. Now with a newer car, if the CO, let's say this is CO, and O2 should be almost balanced. That indicates a balanced air-fuel mixture. Okay? And like I said, when it starts to go rich, ACs follow right behind it. Let's say, oops, that's wrong. Let's say ACs is at 50, let's say 50 parts per million, 50 parts per million or less. I forgot to say this is parts per million, and this is percentage up here, and this is percentage. All right, now when this starts to go rich, it starts to foul out the plugs. As the plugs start to foul out, right, we start to burn less oxygen, and the oxygen starts to go up. That's why you see it starting to elevate, because it's starting to misfire. That makes sense? Yeah, because we're starting to misfire, and that's why O2 is starting to go up. But this here is indication of a rich fuel mixture. So I see something like that, I'm looking for overabundance of fuel. There's too much fuel being dumped into the combustion chamber. And that's one thing about these tests, because you read one book, I think some of these books says O2 is 1 to 2%. I read another book that says 1 to 3%. Now I'm assuming that means with air injection reaction on the car.
Well, see, and that's not specified, because I keep reading and it's like 0.5, half a percent.
Yeah, it's 0.5%. That's why I said it's half. It should be almost matching CO. They should be pretty close to each other. But when it starts to misfire, it's going to go up. All right, so when it starts to misfire, it's going to go up. Because usually I would say CO, let's say CO is 2%. 2%. All right, this is CO. Right? And my O2 is 0.2. Right? That's high CO, low O2 is a rich condition. Okay? That's a rich condition. But if this O2 goes up, this CO goes up to if that CO goes up to 7%, that O2 is going to start to go up also. Because my AC is going to start to foul the spark plugs. You're going to start to get a misfire.
Not burning that oxygen.
Yeah, not burning the oxygen on the fuel correctly. Now here's lean. Here's a lean condition. Okay. High O2, low carbon monoxide, CO, equals lean. You can see that CO is low, AC slightly elevated, O2 is 2.9. Right? Right. This is, let me back up for a second. Remember, CO, insufficient combustion. Right now the O2 stop forming CO2. HC, unburnt gasoline. That means the vapors are the vapors went into the combustion chamber and left without burning. O2 is what's after combustion, what's left over after combustion, and NOx is just basically heat. Yes. So in this case here, this high O2 indicates either too much oxygen went in or wasn't used up. Okay, or you have an exhaust leak, or air pump is on.
Let me ask you something.
Yeah, go ahead.
The majority of times that you see high levels of oxygen, it would probably mean there's not enough spark, right?
Too much air. It could be it could be spark or a leak.
Or a leak. Oh, okay, or vacuum.
Yeah.
Leak. Okay.
Yeah, vacuum leak. Yes.
Well, vacuum leak would drive it.
Yeah, I'm just saying. Presuming that this car has no air pump, you have an air pump, it's going to be much higher. It's going to be high. Now I'm doing this with an air pump disconnected. So you have no air pump in the car, or air injection not working. That's what I'm looking at right now. But if you have an air pump that's working, O2 is going to be high. Okay. Now, again, if you have a lot of O2, that means either that O2 was not used up because of some type of misfire, or even low compression in some cases. Alright, or too much O2 went into the combustion process, meaning you have a vacuum leak, or a lean running car like low fuel pressure. Remember, high O2 means too much air and not enough fuel. Okay. And AC always means some type of misfire, right? The gas didn't burn for some type of reason. Unburnt gas, unburnt vapors means it went into the combustion chamber, then it hit the flame and came out.
So, for example, in this case, if you have both that are high, the oxygen and the hydrocarbons or the carbon monoxide, it would probably be an ignition issue, right?
Okay, now hold on, walk me through that. Let me write it down. So I have high O2 like this, right? High ACs
and carbon monoxide.
Okay, well, that's a good question because I could go both ways. I'm going to talk about that later, but I can actually go both ways.
I'm just thinking because it's unburned fuel and unburned oxygen, right? Mm-hmm.
Well,
so it would more than likely be an ignition issue, right?
Well, it can be because you could have a bad spark plug wire that doesn't. You can have actually a bad spark plug wire, especially in computerized cars, right? and the oxygen does not burn, and it goes past the O2 sensor. Once it goes past the O2 sensor, the O2 sensor does not read unburned gas. It reads oxygen. So it's going to command for more fuel. Then you have a situation where you have high CO, high ACs, and high O2. So you have something maybe like,
so
something like this. Your CO is high, your AC is high, and O2 is high. And that could be caused of a misfire, like an ignition misfire.
Let me see if I understand. So for example, you can have a vacuum leak that's drawing in more air, right?
Yes.
That's gonna push your O2 readings up.
Okay. Yes.
That once that oxygen sensor reads that, it's gonna command more fuel in response, and then that's gonna drive the hydrocarbon and the carbon monoxide up.
Oh, that's a very good question. Okay, that's a very good question. Now here's the thing here. If I have a vacuum leak, that's too much air, it's going to run lean. The computer is going to try to compensate for that by adding fuel, right? Like you just said. But the vacuum leak is large enough, it's not going to, the fuel, you ain't going to see the fuel. You won't see it. Because all you're going to see a command for more fuel by looking at the short-term and long-term fuel term. We're going to talk about that later. But it won't go rich because it's too much air. Okay? It won't go rich because it's too much air. Now, let's flip it this way. Now. The bad wire or bad spark plug, it think it's too much, it think it's lean, and it's going to add fuel to the system to try to fix a lean condition, a perceived lean condition, but the car's not really lean. So now we're going to see high CO, high O2, and high ACs. Because it think it's lean when it's not, because you got a bad spark plug wire, a bad spark plug. Okay? And the other one I was just thinking about, also, yes, this is the other one. Now, here's the other way. The O2 can see bad O2, the O2 sensor can pick up bad O2 and try and give a rich command. It could do that by exhaust leak right in front of the O2 sensor. It thinks it's running lean when it's not. You get a lean command, and I said that wrong. You get a lean condition from the O2 sensor, and the computer adds more fuel to try to take care of a perceived lean condition. Now we're going to have high CO, elevated ACs, and high O2.
Because on the exhaust leak, it's pushing some of those fumes out before the oxygen sensor. So
okay, well, hold up. What fumes are you talking about?
Well, the ones that are going through the exhaust pipe, right?
Okay, you talking about the exhaust fumes after combustion, right?
After.
Okay, we talking about the O2 sensor?
Yes.
Okay, now
the O2 sensor, we have an exhaust leak.
You have an exhaust leak in front of the O2 sensor.
So what I'm trying to ask is that exhaust leak would draw in air? No, right? It would just push out some of those fumes, right?
Hold on.
Would it draw in air as well?
Let me show you something really quick. It's bad draw. Cause that's a good question. I'm gonna tell you why in a second. It's a very bad draw on the O2 sensor. All right, so this is O2 sensor. This is a crack in the exhaust. This is the air fuel mixture you're talking about.
Correct.
Now you're saying that during this process, the air fuel is going this way. The exhaust gas is going out this crack here, right? Yeah. Is that what you're saying?
Yes.
Okay. Now, and the rest of it is going past this O2 sensor. But here's the thing: it's called reverse flow. I think it's called reverse flow. That leak right here is gonna actually pull in air.
But I was asking, so it is pulling air in.
Yes, it's pulling air in. Because the reason I said that was a good question that you asked, because people usually think it's all going out this way, right? Some exhaust fumes are escaping out this way also, right? But in reverse, air is going back in this way. Now, keep in mind, this O2 sensor only picks up air. And no matter what goes by it, air, oil, antifreeze, it don't care. It only reads oxygen. So when this air goes by here, goes by that, it's just going to read it.
That's why it picks up on a lean condition.
Yes. It's just going to read the air. It don't care.
The additional air that's coming in.
Exactly. It don't care about the burnt exhaust. It don't care about oil. It don't care about none of that. It just cares about the air going by it. So yes, this is exhaust leak here, and some exhaust is going out. But in reverse, some air is coming in, right? And that air coming in is fooling the O2 sensor and thinking it's lean. So it's going to tell the PCM, hey, I'm lean, give it more fuel. Then we have a situation, we have high CO, high ACs, and high O2. Right? And the problem is, and the reason to highlight that, because of a false lean condition. And guess what? It's not just a cracked exhaust pipe. You can also have an air pump stuck upstream.
What do you mean when you say that? An air pump stuck upstream?
Yeah, it's delivering. Oops, that was bad. It's delivering the fuel. I mean, the air upstream all the time. Like, you know, what an air pump does. It works up. It goes upstream and downstream. On cold cars, not all of them, but some, it delivers air upstream. That's in front of the O2 sensor. Right? When it warms up, it's supposed to transfer a switch downstream behind the O2 sensor to the catalytic converter. Okay?
Is that now, to warm up the O2s?
Yes, exactly. All right. Now, what happens sometimes, I'm going to draw this. Let's see this. So what happens sometimes, this is an air pipe. I think that's an air pipe. That's going to the air pump. Okay? That's going to your air pump. And air is pushed here when it's cold. Then there's a valve on the system that directs the air behind it to the catalytic converter. This right here is supposed to go to the cat. But if the switching valve here goes bad, or the command goes bad and it stays upstream, I'm gonna have that same amount of air in front of the O2 when it goes in the closed loop.
Okay, so it's gonna be reading that as a lean condition.
It's gonna be reading lean, just like the exhaust leak.
So it could be the air pump, or it could actually be that valve.
Yeah, it could be the air pump, or it could be the air switching valve. An air pump, no, it won't be an air pump, because the air pump just delivers the air. It has to switch back and forth. The valve switches it. It could be a command to the valve or the switching valve. But will act just like an exhaust leak when air is stuck in front of the O2 sensor all the time. Now here is a right here, high O2, low fuel pressure, high O2, lean condition, high NOx. Now you see this here? Lean, low CO, high ACs. I mean, no, low CO, a little high ACs. Look how high the O2 is.
Yeah, it's pretty high.
Now look at the NOx.
Now the NOx drives up because lean condition drives the temperature up, right?
Exactly. A lean condition drives the temperature up. Exactly. If you look at this, you look at this chart here. Where's NOx? Look at NOx. There's NOx right here. All right, this is NOx. Look here. Look at this. At 14.701, right here, that's a balanced air-fuel mixture, a stoichiometric. If I stayed at 14.701, NOx would be high. You can see as it goes lean, it gets even higher. It starts to come down when it misfires. We have a lean misfire. That unburned gas will wash down the cylinder walls and cool it down. So in a lean condition, that can cause a NOx increase. But at the same time, at 14.7 to 1, HC, CO, and O2 is almost damn near balanced. And CO2 is its highest point. That almost makes no sense, right? Because you have at 14.7 to 1, AC and CO is low. CO2 is high, which is great. But at 14.7 to 1, we're creating NOx because it's too lean. In order to control NOx and AC and CO, we need a three-way cat. And a three-way cat has to have an O2 sensor that's switching efficiently from lean to rich to have the ability to take care of all three gases at the same time. That's how a three-way cat works. It works along with the O2 sensor to take care of the three gases. That's why you never change the cat. You never change the cat unless the O2 sensor is working. We're going to talk about that later also. But to control the NOx, AC, and CO at the same time, the O2 sensor has to be working along with the catalytic converter. Now look at this. On this side of the chart, we got 14 pounds of air to 1 pound of fuel. I used to heard it was parts. Now here it's pounds. But anyway, so you got 14 pounds of air to 1 pound of fuel. As it starts going down, we get less air. We get less air. It gets richer. Look at the CO. This is CO here. Right? So it's line at here 14.7 to 1 is okay. But as soon as it get less air for any reason, it goes up. Goes rich. So high CO is an indication of too much fuel. Either not enough air, right, or too much fuel. You have CO condition. Now look at this. Here's HC. It's a follower gas. It follows right behind CO. And the reason why I'm saying that, because when the plugs start to fall out because they turn black, you start to get a slight misfire or unburned gas. I should say unburned vapors. And CO is going to follow right behind the HC is going to follow right behind the CO. So when the CO starts to elevate to a point, HC is going to start to come right behind it. But in the case of a rich condition, look at the O2. High CO and low O2 is an indication of a rich condition. So you have high CO, low O2 is running rich. High CO, slightly elevated HCs, and low O2 is running rich. But on the other side of the chart, look at this side of the chart. Oh, I forgot to say something. On the rich side of the chart for NOx, look at this side here for NOx. When it runs rich, NOx comes down. Look how NOx falls down. Because a bunch of chambers running cool, it comes down. Versus when it's lean, it runs hot and goes up. Now on the other side of the chart, look at this. On that lean running car, CO is low, but O2 is high. So in this case here, we have high O2, low CO, indication of a lean running car. But when it starts to get lean, ACs also start to go up because they're going to start to miss. Or you're going to have insufficient combustion because there's too much air and not enough much fuel. And they're going to start to misfire. So ACs start to go up. Now remember on the ASE test, especially on the ASE L1 test, gotta remember this. We talking about lean. Okay, we talking about lean and rich. Okay, but remember on the ASE L1 test, they're not going to ask you the car running lean or rich. They're going to actually tell you to fix it. You get what I'm saying? So when it says, okay, they're gonna give you numbers, all right, in a scenario or a problem, and say we can cause this rich condition, we can cause this lean condition. But they're not gonna say rich and lean. They're gonna give you numbers. So right now, what we're doing is you're gonna have to identify: is it lean? You have to identify: is it rich? Okay, that's the first thing you do. Identify what's going on. Then you apply the question to the answer. I like the example I gave you earlier. I'm gonna have an example coming up also. But you gotta apply the problem to the condition. And then to do that, you gotta identify it first. All right, here's some other things. Fuel injectors can even damage the ECM or PCM. Excessive current draw, short injectors, right? Injectors not working correctly could cause a lean or rich condition also. Or damage the computer if it's shorted. Here's a picture of a fuel injector that can even damage the PCM. Here's your injectors. Imagine these ohm out of 12-15 ohms each injector. If it's shorted, remember a short means anything less than the specifications given by the manufacturer. So if this was an injector that was supposed to be 15 ohms, 12 to 15 ohms, and it reached a 0.5, that's a short. And remember Ohm's law, right? When you have less resistance, you draw more current. And to draw more current on this driver, the injected driver can burn up inside the PCM. Or the PCM can shut off the car, turn the car off. It can answer the question either way. I've seen a situation where they said a car wouldn't start up, and they gave you specifications for the injectors. And one of the injectors was out of specifications. That was a short. That could cause the PCM to turn off to protect itself. And the same thing for sensor too. A sensor can short out and the PC can turn off to protect itself. Or we can have a car we can have a situation when the injector has too much resistance that interrupts the spray pattern. Or a partially shorted injector, not totally shorted out like 0.5, but say it's like 10 or 8. The spray pattern may be different and cause a mixture problem. Now here's another example of an EGR valve that's not working. It could cause high knocks, right? But look at the readings here. What do you see in these readings?
Let's see, RPM. I'll assume it's idling.
Now this card actually running rich also. I got high CO. Let's say I should have put CO down here. Let's say this card has a CO of 4%, right? And 8 Cs at 300 parts per million. Now, first off, you identify as running rich. Okay. Now, on the answer, you have to find out why is it running rich. Because now you identify as running rich. Now you have to figure out why it's running rich.
What I notice is it's idling. It's at 800.
Yes.
Partial acceleration. But the EGR is commanded off, but it says that the EGR is at 50%.
Exactly. But
so meaning it's stuck open, partially open.
Right. How about this?
Saying 0.
How about that?
And then the map, yeah, the map's pretty high, meaning there's barometric pressure in the intake.
You mean a load on the intake?
Load, yeah.
It's a load, yeah.
That's about all I noticed. I'm not sure what else I'm missing.
So let me ask you this: if the test, an ASE test says pick a problem, what would you say the problem with this car? They say pick an answer. What would be your answer to the problem with this car? You already know it's running rich. What would be your answer why this car is running rich? What you see on this picture here?
I would say it's the EGR is stuck partially open.
And you'll be absolutely right. And now here's the thing. Guess what? They probably give you a DTC, right? And that's a trouble code for a map. For the map sensor. Right? They probably give you a code for the map sensor. Because you know why? It's out of range. That's supposed to be like maybe a half a volt to 0.9, maybe up to a volt. And it's 3.4 volts. But you're exactly right though. The EGR valve open like this is causing a vacuum leak. And what sensor affects vacuum? What sensor uses vacuum? The map sensor. Right? But guess what? Their choices might be, some of the choices are some of the ASE choices are going to be, one's going to be a map sensor. Let's see if you pick it or not. All right, then there's going to be the EGR in there somewhere, carbon the EGR valve. It might say, hold up, it might say EGR valve stuck closed. All right, they might say map sensor. They might say EGR valve partially open, or EGR valve stuck closed. Or they might say the car was in, something else, in the wrong gear. Something silly. All right, but the key is you're right though. This number here and this number here don't disagrees with each other. So when you looked at that, you looked at that correctly. This and this disagree with each other, and the reason this is high is because of this.
Yes.
Right. But a tester probably give you a code for map sensor and not the EGR. Okay. And see do you bite. That's why I say identify it first. It's running rich. Read the question, identify it, then come here to see what's going on. That's what I do. I always read the question. I try to identify what's going on. I read my choices. Then sometimes I read the question again. Then I pick an answer. And remember, you only got 2 minutes for this.
Yeah.